So far, we've covered a lot of the back-end services that we'll need to build our web applications. We've talked about Python, we've talked about running an app engine, we've talked about HTML and CSS, we've talked about storing data, but we haven't really talked about how this is operating and how this works just yet. And today we're going to talk a little bit about the virtual machines that are going to run this. And virtual machines are actually a pretty important part of cloud hosting today. So why do we care about virtual machines? Why do we want to use those? Well, the number one reason is probably flexibility. When you think about a virtual machine, you have something now that is essentially software, so you can start up new virtual machines very easily. Once you have the data associated with that application, creating, replicating, deploying a new virtual machine can be done in pretty much any data center in the world, and that might be a little bit more effective than trying to build a physical machine. You can also enforce certain constraints. So outside of this particular application, you might want to be able to say that you're working off of a machine with lower memory. You might want to work off of a different type of processor configuration, and enforcing some of those constraints so that you can simulate different environments can be really effective in a virtual machine. But this ease of replication is actually really important when we're talking about hosting an application that needs to serve a global audience. Instead of trying to move requests all around the world, you can just replicate the virtual machine itself and then serve requests more locally. You can also divide a single machine into different pieces, and this can be really effective. Servers can be expensive, and you might end up having a very heavyweight machine to do something as simple as just service some HTML and maybe look up a couple of simple queries in a data storage system. So dividing a single machine into many pieces so that you can time slice that and share it can make it much more cost effective so that you're only paying for the compute that you use. You can also, in the opposite direction, you can combine many distinct physical machines into a single virtual machine. This can be effective if you want to have a much more capable piece of hardware, and this way you can kind of take a group of machines and then operate them as a single machine. And you have a lot of different configuration options in a virtual machine. So it used to be, 20 years ago, that virtual machines were seen as slow and more limited, and I think today now you can build virtual machines that are much more efficient to operate, and much more capable of different configurations, different operating systems, different memory configurations, different storage configurations, and this can allow you to do a lot of different things without having to go out and buy lots of different hardware. Now, this ease of replication is worth thinking about a little bit further, because in a global environment you're going to care a lot about proximity. Basically what we mean there is that where your users are versus where you're serving the request is actually pretty important, because we're limited by the speed of light. Even though we think of light as traveling very quickly, it's still a cap on how quickly we can communicate across the world. And the next slide is going to have a sample of this wondernetwork.com table that shows you from Pittsburgh how long it takes to communicate to other places. Since a VM is basically just software, it can be copied to other locations for easier serving. So if you think about your App Engine applications, they're a limited set of files operating within a particular configuration for hosting those files. So moving those around is actually rather simple and rather quick. If you suddenly get a burst of traffic in, say, Bangkok, you're able to boot up a VM there and service those requests more locally, and that can be really helpful for responding to your users' requests more easily. Now, this is a set of ping times from Pittsburgh, and you can see that a lot of these are pretty long. We think of 252 milliseconds as not very long, in absolute terms, but when you're talking about sending requests back and forth, and maybe there are multiple requests being sent back and forth, and your system has to keep up with all of these, that latency can really cause a lot of problems. Half a second of delay is actually going to be somewhat expensive in certain applications, and this can go up beyond 300 milliseconds if you're looking at places, certain places in India from Pittsburgh. So going all the way around the globe does have this delay, and 300 milliseconds can be a pretty perceptible delay, when you're dealing with things that are going to require a little bit more real-time response. So this is one of the reasons why we like to have our resources, our data storage, our serving all a little bit closer to our users, because it can improve that user experience. And when we're talking about the machines that we're running, it is useful to think about the different pieces that we're working with in this class and where they're actually operating. So our Python is actually happening on the server, in the virtual machine itself. That's being executed, that's being interpreted, and we're only getting the results. So the other three technology or language technologies that we're using, JavaScript, HTML, and CSS, all of these are executing in the browser. So Python is going to run the logic in the back end. It's going to communicate to your data storage, but your JavaScript, your HTML, and your CSS, those are all going to operate directly in the browser. So these are all technologies that are downloaded, basically text files downloaded into your browser. Your browser interprets those, and that's where you render your view, your styling, and where JavaScript is handling some of the interaction and execution within the browser. Now, on the opposite side of this, we use a virtual machine for our development in the Cloud Shell. So when we start up our Cloud Shell, that's going to be a really low-spec virtual machine that's limited but can be pretty effective for development, for testing out our application. And the reason we use it is because it gives everybody a common starting point, an easy place to get moving with these things. And then App Engine is sort of a managed live virtual machine. It's actually containerized, but we can kind of think of it as live VMs that are deployed as we need them for hosting our application, which is why we're able to replicate them in many different places worldwide. So that covers just a basic overview of what we need for virtual machines and how they're going to operate. They do provide us certain benefits, and I think that using virtual machines allows us to scale our applications. As the demand increases, we can throw more and more and more servers at our problem so that we can provide a really good, really low latency user experience. Thanks for watching.